record the sessions, and after I process these files, I send you a link. I'll send it to whatever email you signed up with.
Okay.
And it probably won't be until tomorrow morning. It takes my computer a couple hours to process these files. They have to be converted to WMV files. And
all right.
then the link you get will take you to a YouTube file, if you like, where you can review the session. Okay, so what are we going to talk about tonight? What are we going to work on?
Solving inequalities.
Okay.
And then,
can you verbalize them? If you can verbalize them, I'll write it on here and we can go about solving them. If
sure.
you have problems that, like, interpret a graph, then those kind of problems you need to take a picture of with your camera and send it to my email. And then I can bring it up on the screen so that we can both look at that graph.
Okay.
But as long as it's problems that can be verbalized easy enough, then it isn't necessary to do it the other way.
Yeah, they can all be verbalized easily. But tonight my homework is over just some of the few things that we've learned in our unit. So along with those inequalities, we're solving quadratic formulas and completing squares.
Okay.
Or completing the square.
Okay. Let's do any of the three that you want to do, whatever you're having the most difficulty with. Let's talk about those.
So first off, solving inequality.
Okay. Give me one.
X squared minus 2x minus 8 less than or equal to 0.
Okay. These are not as easy to solve as regular inequalities. In other words, if I had x plus 4 is less than 0, I can subtract 4 from both sides and I get x is less than minus 4.
Yep.
Okay, so linear inequalities are very easy to do. Quadratic, not so easy. First of all, we need to factor it. This is factor into.
So, x is...
What kind of calculator do you have, Nate?
I have TI-83.
Okay. I was going to say the new one that they're recommending everybody get is the TI Inspire CX. And that actually allows you to put in a function and it'll factor it for you. But we're going to have to do it by hand. So you know how to factor this, or you want me to go through the steps?
Isn't it negative 2 and 4?
Well, it's negative 4 and plus 2. But let's go back and see how we got that. First of all, it's x and x. That's clear enough.
Yep.
The fact that it's minus 8 means the signs have to be opposite.
Okay. That makes sense.
And now we're looking for factors of 8 that subtract, because of that minus sign, to the number 2. Well, that's 4 and 2. Now put the bigger factor, 4, with the sign of the middle term. So the 4 goes there, the 2 goes there.
Okay.
Okay. Now what we have to do is, in order to solve this, we have to use a line chart, which is basically a number line. And first thing we need to find is the critical points of this, which are whatever values of x make that 0, or that 0, or if there were a denominator, makes that 0. So what are my critical points?
Negative 2 and 4.
Let's plot those. And I purposefully leave 0 off my graph because 0 is not a critical point here, so I don't want to mistake it for being a critical point.
Yep.
Now, the way I solve it is I test numbers to the left of my critical point, in between my critical point, and to the right of my critical point. So let's test minus 3. So if we plug minus 3 in here, what is the sign on this term? And that's all we care about. We don't care about the number, we just care about the sign. It's negative, right?
Yeah.
This would be what?
Negative.
Negative times negative is positive, which means every point to the left of minus 2 results in a positive number.
Okay.
Now let's check points between minus 2 and 4. The easiest one to do is always 0. So 0 would result in a positive there, a negative there. Positive times negative is negative, so all of these are negative.
Okay.
Now the third and last point we need to check is to the right of 4. So if we choose 5, this is positive, this is positive, positive times positive is positive. So that's what our line chart looks like. So
Okay.
now, what's the solution? Since we need it to be less than 0, we're looking for everywhere that it's negative.
Okay.
So x has to be greater than minus 2 and less than 4. And that, in a nutshell, is how you do rational inequalities.
Okay. That
And
makes sense now.
it becomes a little tougher if it is something like this. Let's do one more, because it becomes a little tougher when it's a quotient, when you're dividing two things. In other words, if I said x minus 5 divided by x plus 3 has to be less than 0. Okay, how are we going to solve this? What are my critical points?
5 and negative 3.
What's the first point to test?
The negative 3 point. Negative.
A number to the left of that.
Oh, so just negative 5, I guess.
Okay, that's fine. So negative 5 gives you, what's the sign on the numerator?
So negative 5. Negative.
What's the sign on the denominator?
Positive.
No, if I substitute negative 5,
Oh, negative.
okay, negative divided by negative is positive, so it's any number to the left of 3, to the left of minus 3 produces a positive result.
Okay.
Okay, let's test numbers between minus 3 and 5. Give me a number between minus 3 and 5.
2.
Okay, what's the numerator?
Negative.
What's the denominator?
Wouldn't it be positive?
What's the quotient?
Negative. There we go.
And then to the right of 5.
6. Let's do number 6.
That would be positive. That would be positive. These would all be positive. In other words, is all you have to test is one number, and it tells you what everything out to negative infinity is going to be.
Okay.
Okay, so if I'm looking for everything that's less than 0, again, that's my result. X has to be greater than minus 3 and less than 5. If the question said greater than 0, well, now my answer is x has to be less than minus 3, or x has to be greater than 5 if this inequality was going in the other direction, because we would be looking for pluses, not minuses.
Okay. So in a way, it's more analysis than actually. It's like analysis of the equation.
Yeah, this is always going to be, if you don't have 0 on the other side, move everything over to one side and make it 0. And then you're either going to have the product of two functions or the quotient of two functions. And either way, use a line chart.
Okay.
And of course, if this is greater than or equal to 0, then just makes those greater than or equal to 0.
Okay.
Quadratic formula. You know what it is?
Yes, isn't it x equals plus or minus b?
Just minus b.
Square root of b squared minus 4ac over 2a.
Will they always give you this, or will they expect you to memorize this?
I memorized it, but they provide it for us on the test.
Okay. One easy way to help memorize this is notice what the first half is.
Minus b over a.
What is minus b over 2a equal to? That's the vertex of a quadratic.
Okay.
Back before you learned the quadratic formula, you probably learned how to find the vertex of a quadratic.
Yeah.
And it was minus b over 2a. So knowing that that's the first half of the quadratic formula helps memorizing the quadratic and also the vertex. And
Okay.
this part inside the radical is called the discriminant. It has its own name because sometimes it's very useful to analyze the discriminant as your first step, because if that's positive, we're going to have real solutions. If it's negative, we're going to have imaginary solutions. And if it's 0, we're going to have exactly one real solution.
Okay.
So give me a formula that we would need to use the quadratic to solve.
So 6x squared plus 6x minus 21 equals 0.
Okay. Can I simplify this at all before I begin?
You can simplify it by 3.
Yeah. And that's going to make things easier, because if we use these numbers, we're going to have some big numbers in the quadratic formula, and it makes it more likely that we might make a mistake. So let's factor out a 3. Now I can divide both sides of the equation by 3, getting rid of that. Because when I divide 0 by 3, I still have this. So if I'm going to solve this, I might as well solve this problem here that has smaller coefficients than the other one. Right?
Okay.
So let's solve it. What's minus b?
Negative 2.
Plus or minus b squared
Which is 4.
minus 4ac. It's a, and what's...
Negative 14.
Okay, so a is 2, c is minus 7. All over what?
2a, so 4 again.
Okay, let's simplify this. Minus 2 plus or minus, what does this radical become?
Let's see. Oh, yep, I got negative 62.
I think it's positive 60. In other words, these two negative signs turn into a positive, so you have 4 plus 56, 60.
Yeah.
Okay. What does square root of 60 reduce to? What does that equal to?
Square root of 60.
Try to find factors of 60 where one of the factors is a perfect square.
So 2, 30, 4.
Those are the only two I can think of.
Okay.
In other words, 30 and 2 works, but
Yeah.
none of those numbers are perfect squares. And when you're trying to simplify radicals, you're trying to pull a number out, a whole number. In other words, I can now make that equal to 2. So this is 2 root 15.
Yeah, I usually use have you heard of the tree method?
Yes, I have. Where you
I
take
usually
6.
just use that.
Okay, so you break that into 30 and 2, and then you break that into 15 and 2. And since you have
Yeah.
two 2's, you have 2 squared times 15, and when you take the square root of 2 squared, you get 2. Okay.
Yeah.
So I can replace my square root of 60 with 2 root 15. Now, 2 root 15 is 2 root 5 times 2 root 3, but that's not more simple. That's got 3 terms in it instead of 2. So root 15 is actually more simplified than root 5 times root 3. Okay, so now we can simplify this a little bit more because we have minus 2 over 4. And you really want to put these in the format of 2 different numbers. Well, what is this equal to? That's minus 1/2 plus or minus root 15 over 2. You see how I got that?
Wait, so did the 2 root 15, did the 2 cancel out?
This 2 went with the 4 to become 1/2.
Oh, okay, I see.
This 2 went with the 4 to become 1/2. So all I did was I split this up into 2 fractions.
Okay.
Isn't so necessary when you have real solutions, but it's very necessary if this is imaginary. In other words, had this been a negative number and I would have been dealing with I, you always want to put your answer in the form a plus bi, where a is the real part, that's the complex part.
Yeah.
Well, even though our answer to this problem is real, not imaginary, it still has this irrational part to it. So the best way to express this answer is not to convert root 15 to a decimal, but the proper way to show this answer is it's minus 1/2 plus root 15 over 2, or x equals minus 1/2 minus root 15 over 2. So that's one answer. That's a second answer.
Okay.
All right, completing the square. Let's take that exact same problem, and instead of solving it by using the quadratic formula, let's complete the square. We're going to get the same thing. Let's again take that 3 out, so I really have 2x squared plus 2x minus 7 equals 0. That's what I'm trying to solve. Let's not do that one. There's a reason why I don't want to do that one as the first one. Let me make one up. No, that factors too nicely. I don't want that. Factors of 7 that add to 6. There aren't any.
Yeah.
So I can't factor this. I could use the quadratic formula, but the quadratic formula was actually derived by completing the square. So another way I can solve this is by completing the square. Well, if I want to complete the square, I'm going to put the number on the other side. So
subtract 7.
And And now I'm going to complete the square on the left side of the equation. Well, how do I complete the square? I take half of the coefficient of the x term and I square it. And I add it. So half of 6 is 3. I square it and I write plus 9. Well, I can only do that as if I add 9 to the other side of the equation also, right?
Yep.
I mean, I can't arbitrarily just write in plus 9. I can only do the same thing to the left and the right side of the equations. So at this point, I haven't changed anything, right? In other words, this second equation is the same as that equation.
Okay.
I've just manipulated it. Well, the reason I took half of this coefficient and squared it and added it was because now I can write this thing as x minus 3 quantity squared. And I will always be able to do that when I'm completing the square. Equals 2. Minus 7 plus 9 is 2. So I still haven't changed it. But notice that now I can solve it a lot easier. How do I solve this? What's the step, the next step to solving that?
Wouldn't you square the x minus 3?
You take the square root of both sides. In other words, what I'm trying to do is eventually isolate x all by itself.
Okay.
Okay, I can't isolate x until I take the square root of both sides. So when I take the square root of the left, I get x minus 3. When I take the square root of the right, I get that.
Okay.
Plus or minus square root of 2. Now, when I solve it, I get x equal 3 plus or minus root 2.
Okay.
Now, that was one I made up. That wasn't the one we originally were looking at. Okay, but notice how similar the answer looks to the quadratic formula.
Yeah.
It's 3 plus or minus, and it will always be, because whenever you take the square root of both sides, you end up with plus or minus on the other. So when I solve this thing, I'm always going to get an answer that looks just like the answer I would have gotten had I used the quadratic formula. I would have gotten 3 plus or minus root 2.
Okay.
Okay? That is an easy complete the square. Let me give you a hard complete the square, or harder. Now, again, we want that constant on the other side. But now, in order to complete the square on the left side, I have to make sure that the coefficient of the x squared term is 1. So I have to factor out a 4. So I have to write it like this. In other words, I am not ready to complete the square until I have that coefficient as 1.
How come you wouldn't factor out 4x?
Well, because I'm trying to complete the square. And when you complete the square, you want your x squared term and your x term still there. That would not help me solve the problem if I factored out 4x. Whereas if I can somehow represent this quantity as x minus h squared, then I can solve the problem. So I have to complete the square on what's inside the parentheses. So what do I need to do?
Find the, wouldn't you find the...
Take half of this coefficient.
And then square it.
Square it and add it.
Yep.
So what am I putting here?
1.
So when I wrote that 1 in, how much did I add to the left side of the equation?
Just 1. Or 0.
Actually 4. I got this 4 out here that's multiplying this. So the moment I wrote a number in here, I actually added whatever that number is times 4 to the left side of the equation. So to counterbalance it, I got to add 4 to the right side of the equation.
Okay.
That's always the way completing the square works. Okay, now I can write what's in the parentheses as an x minus h squared, and it's always x minus whatever half that was, in this case 1, quantity squared, equals minus 3.
And then you square root.
Not yet.
Ooh.
I want to divide by 4. In other words, remember I'm trying to isolate x. So the first step is going to be divide by 4. So I have x minus 1 squared equals minus 3/4. Now I take the square root of both sides. X minus 1 equal plus or minus the square root of minus 3/4. You see that step?
Yeah.
Now my answer is x equals 1, this 1 moved over, plus or minus the square root of minus 3/4. That can be simplified a little bit. First of all, that's an imaginary number. So what is that in terms of I? What is this if I want to convert it to I?
Equals, isn't it just 3/4 I?
Square root of 3/4. In other words, this would be the square root of minus 1 times the square root of 3/4. And this is the I part. So this would be square root of 3/4 I. And square root of 3/4 is square root of 3 over 2. So this becomes 1 plus or minus square root of 3 over 2i. And now I have it in A plus BI format, which they always wanted it. So my answer is 1 plus square root of 3 over 2i and 1 minus square root of 3 over 2i. Which means there were not real solutions to this problem that I made up. Only imaginary solutions. There's no real value of x that makes that equation true.
Okay.
You've had imaginary numbers, right?
Yes.
This year? Okay. Yeah, the only tricky part of this was factoring out that 4. So now let me give you a really hard one. So let's move the 7 over. And now let's complete the square on that.
Alright, so you take out the 4 first.
Okay. What's left behind?
X squared minus 3/4 x.
You got to divide this by 4.
Oh.
Because we're going to factor out a 4 from this total expression. So it would be 3/16 x. Right?
Yeah.
In other words, I haven't changed it. If you redistribute this 4, you get 4x squared minus 3/4 x.
Okay.
Okay. Now what's the next step?
You divide negative 3/16 by 2 and square it.
So that's divided by 2 is this. Squared, it becomes plus 9. Well, I made up these numbers. I didn't mean to make up big numbers like this. But what's 32 squared? I'll just write it as 32 squared.
It's 1024.
Now, since I wrote that in on the left side of the equation, what do I have to do to the right side of the equation to balance it out?
Add 9 over 1024.
Times 4.
Times 4, okay, so...
Don't forget that part. That's the part that's really easy to forget.
Yeah.
So I want to add 36 over 1024 to the right side.
Oh, because you multiply the 4 and 9?
Right. In other words, the moment I wrote 9 over 1024, I didn't add 9 over 1024 to the left side of the equation. I added 4 times that.
Okay.
So I have to add 4 times that to the right side of the equation also. Now I can write everything that's in parentheses as x minus 3/32 squared. In other words, the act of completing the square always allows you to write this term as x minus h squared, where this number is the number you got when you took half of that.
Okay.
Okay? And now what do I have over here? Gosh, I don't know. Minus 6 and something. I didn't mean to make these numbers so big. But the rest of the problem should be fairly straightforward to you. Let's say that it's 6.5. It's not 6.5, but for practical purposes, I'm going to call that 6.5, which is minus 13 halves. Now what?
Divide by 4?
So that makes it, I can get rid of that 4, and I make this an 8. Now what?
Square root.
So I got x minus 3/32 equals what?
Square root of 8.
Plus or minus. Don't forget that plus or minus, and it's minus 13/8.
Oh, okay.
In other words, I'm taking the square root of both sides.
Okay.
Okay? So the final answer, I'm going to move this over, put it first, because that's where the rational number belongs, is first. And this becomes minus, or 13/8 I, square root of 13/8 I. And this actually does simplify because the denominator is square root of 8, which becomes 2 root 2.
Yep.
So that's how you do completing the square.
Okay.
Now, there's 2 places to use completing the square. One is to solve a quadratic, like we just been doing. The other is if they say, take this quadratic and put it in standard vertex format. This is standard vertex format. Well, if I said this, and I want to put this into standard vertex format, I do it a little different. I'm still going to complete the square, but I'm not going to move the number to the other side. Notice why. Standard vertex format has this k on the right side of the equation. So all I'm going to do here is I'm going to separate the x squared and the x. I'm going to move the 7 out here, and I'm going to complete the square inside those parentheses. And I'm going to end up with vertex format instead of solving it. So what goes in the parentheses?
X squared.
What do I have to add here?
The model. So you divide negative x by 2, then square it. So
you divide the coefficient of this by 2.
Yeah.
So the coefficient is 1. So it would be 1/2 squared, which is 1/4. Now, I'm not going to balance it out on the other side of the equation. I'm going to balance it out on the same side of the equation. So what do I have to do? That I just added 1/4. What do I have to do to the right side now?
Add 1/4 or subtract 1/4.
Subtract. If I was balancing out the other side of the equation, I would add 1/4. But since I'm balancing out the same side of the equation, I have to subtract 1/4. In other words, this right here is the same as this right there.
Okay.
It just has a plus 1/4 and a minus 1/4. Well, now I can represent this as x minus 1/2 squared, always, minus 7 1/4. Notice now we have it in vertex format.
Yep.
What's the vertex? It's H and K.
So it's negative 1/2 and negative 7.
Positive 1/2 minus 7 1/4. In other words, look at the standard format. It's
it's kind of like opposite of it.
It's x minus h. In other words, here's the standard format right here. Notice that it's minus h, so when I got x minus 1/4, h is 1/4, plus 1/4.
Okay.
And I got minus 7 1/4, well, it's plus k, that means k must be minus 7 1/4. So my vertex would be right here, and I'm well on my way to graphing it. Even though I haven't solved it, I haven't come close to solving it, I still use completing the squares. So completing the squares is used to take a quadratic and put it into vertex format, or it's used to take a quadratic and solve it, solve for the zeros. So either one. And when you get to conic sections, which will be coming up this year, circles, ellipses, hyperbolas, all of those use completing the square also. So completing the square is actually used in 3 different situations that I can think of. We've just covered 2 of them tonight.
Okay.
So we've done solving quadratics using the quadratic formula. We've done solving quadratics using completing the square. We've done taking quadratics, putting them into standard format using completing the square. What else did you mention was part of what you were covering today?
Inequalities.
And we've covered that. Products and quotients.
Correct.
Okay, the only other, you know what this is, I presume. You solved that?
Trying to think.
In other words, there's only one difference between inequalities and equations when it's linear like this.
Yeah.
And that is whenever you have to divide or multiply by a negative number, you have to change the direction of that.
Yeah.
So since I need to divide by -2, that makes x over there, makes -1 over there, and it turns that around.
Yeah.
So that's really the only difference between solving linear inequalities and equations, is making sure that you always keep an eye out whenever you're dividing or multiplying by a negative number.
Okay. And
of course, when you have quadratics, it's a lot different. In other words, when I have x minus 2 over x minus 1, notice I cannot multiply both sides by x minus 1.
Yeah.
If I did, this problem would reduce to x minus 2 has to be greater than 0, and that's not a true statement. The reason is because when I multiplied both sides by x minus 1, I didn't know whether that was a positive or a negative number. So I don't know what to do with the inequality sign. So be very careful when you're solving inequalities by multiplying or dividing by variables. You shouldn't do it. You should never multiply or divide by variables. In other words, if I said 6x is greater than x, solve that.
So you divide by 6.
No? And you definitely do not divide by x, because we don't know if x is positive or negative, so we won't know whether to turn the inequality sign around. So
Okay.
the way I solve this is to subtract x from both sides, leaving 0. Now factor out the x, and I have 5x is greater than 0. So
Okay.
x has to be greater than 0. Actually not. Well, yes, it does in this case. Yeah. I didn't need to go through this. 6x minus x is 5x. So I could have just said 5x right away. All right. Do you have any problems of the nature of what we're talking about that you want to take a stab at?
No, I think all that just cleared everything up.
Okay.
So I think I'll be good.
Okay. Nathan, can you give me an email address that I will use for two different things? One, I will use it to send you the link to this recorded session. And the other thing is I will send you an invoice for the session. And I don't know if I want to send that to you or your mom or your dad. Whose
You can
email?
just send it to me.
Okay. What's your email address?
Adams Nate 14 @gmail.com.
Okay. Did I spell it right?
Yes.
Okay. That's where I'll send both things to.
Yes.
Okay? All right. Well, I hope you found this helpful.
I did. Thank
And
you.
you're comfortable with scheduling online? So,
Yes, I am.
okay. I will talk to you the next time I talk to you then.
All right. Thank you.
All right, Nate. Bye-bye.
Have a good one.